Okay, so today's question is longest balance subarray part 2. So you are given an integer array nums. A subarray is called balance if the number of distinct even numbers in the subarray is equal to the number of distinct odd numbers. We have to return the length of the longest such subarray. So suppose this is the array 2543. We have to take count of the distinct odd and distinct even number, and we have to return the, if both are equal, we have to return the largest subarray. Here the whole array is the balanced one, so we have returned its length. So it is same as the previous question, but in that we use the brute force because constraint was only till 1500, but here is till 10 power 5, so we can't do brute force. So we will do one thing, we will use the segment tree. Segment tree will help us to get the particular anything like minimum, maximum, or the sum of the particular range in much lesser time as compared to big O of n square. And what we will do, we will give a token of +1 to the even numbers and -1 to the odd numbers. And suppose if the sum of all is 0, means +1 has been cancelled by -1, that means it's a balance array. So this is the logic we will be using. Let's try to code this. So let's take first the len of nums. Then we can create a segment tree. We'll create this class afterwards. Let's first call it here segment tree of n and nothing but the length of the nums. Okay, now we will be any index between nums from L to R. L will be 0, R to n -1. So let's take the max value among them. Max value can be max of nums, and simply set last is equal to last is nothing but last will be the last occurrence of that element in an array. Okay, so we will set each 0 before, so max v +1. Okay, now we can simply set our answer to 0 currently, and we can simply enumerate. So for r comma x and enumerate, we will get both index and the values with enumerate, and simply nums comma, as you can say, it start is equal to 1 as 1 base indexing. Now simply what I told you, we will set a token to each value. So if it is even 1, if it is odd, then -1. So simply say w is equal to 1 if x modulus 2 is equal to 0, else we can set it to -1. Yeah, now check what is the value of the last is stored in this x, if this value has occurred before or not. So we can simply check that old is equal to last of x. If it is 0, then yeah, it's the first occurrence. If not, it's not the first occurrence. We have got this value before too, so we can check if old is not equal to 0, means this value has seen before. We can simply add it to segment dot add. If old is not segment, we can add simply 1. 1 is nothing but the index. Then what will be the range of L and R? 1 to n. And then we QL and QR will be nothing but that query range. So 1 comma query range is still old, and we have to remove this. Already a w weight will be there, so we have to remove that. So for that we will be adding -w. So this is for removal. And now for adding that value again to the new index, as we want only the last occurrence of that particular value. Okay, so we simply add segment dot add. Index is 1, then starting from 1, L and R range is 1 to n, then 1 to R is QL and QRO query, and then add w value at here. And now we can update it by last x is seen at this value. Okay, now we need the leftmost part where we get the zeros. Okay, 0 means the array is balanced. So how can we do that? We can simply create a method for that. So let's first call it, then we will work on the segmented tree. So dot leftmost 0, let's give it this name, same star index, then L and R range, then query range, suppose if we see that L is not equal to -1, means we have got the balance sub array, then we can simply compare it with the answer is equal to max of answer comma what will be the length r minus L plus 1 of that particular sub array, and we can simply return answer. Okay, so we have created the base structure of our code. Now we can go and simply create this segmented tree. So let's try to create that. Now we'll create a different class for segmented tree. So class segmented tree, let's define the init. So define constructor for this init, which will take two values, self and the n itself. Now we can say itself dot n is equal to n, refer to the object, then we can say size is equal to at least 4 times, so 4 into n. Then the minimum array we can create, self dot minimum is equal to, initially it will be 0 into the size. Okay, now we can set a max value, which will be nothing but the 0 into size, and finally we can create one more value called lazy one. So self dot lz equal to 0 into size. Okay, so we have created for the minimum, which will keep track of the minimum value in the segment, this will keep track of the max value in the segment, and this will be used to add a value in the segment. Okay, now add, we have called here now this add one, so this will help us to add the value in the segment. Now we can simply create an apply function which will apply this all value, so it will be refer to the object self, and nothing but pass the index and then a delta value to be added. Okay, pass a delta value which needs to be either be +1 or -1. So yeah, now we can simply say self dot minimum of that idx or that index will be what is, so it will be added by nothing but the delta value, so the delta value which we have passed here. And similar case with the maximum, self dot max of particular index, minimum will also increase, maximum will also increase by delta. And now the lazy one, self dot lz of x will also increase by delta. So this creates our apply function. Now let's create a push function to push the value, to push this delta value to each range. So simply define push mark and pass the index for which it needs to be pushed. Okay, now we can simply set if check first, if self dot lazy, okay, self dot lazy is not equal to 0, means there is a value delta which needs to be added. So we can first take this value, t is equal to self dot lz of what the value, your lz of what is the index given to us, it's idx. Okay, index is idx, yeah, is equal to self dot. Now we can simply apply. What apply we will do, it will increment the both minimum max and laziness value. Okay, so we can simply go self dot, call the apply function, apply method, and go idx. Yeah, twice the idx and pass the value to be applied. Similarly, you can also apply self dot at the odd position, so idx into 2 plus 1, pass the delta value which needs to be added, and at last you can simply set this lazy value to the 0. So self dot lz of idx is equal to 0. Yeah, so this completes our push. Definition. Now you can simply create this what else, so the add function we have to create this segment dot add. So let's do that. Define add, and we can pass like self comma index, then we can pass the range, original range L2R, then the query range Q1 Q2, your query range left we can put NQR. Okay, query range right, and simply pass the delta value to be added. So this will be the attributes needed for this function. So suppose if our query right is itself less than left one, or our right is less than query L, okay, that means this it is not possible and we can simply return from here. Now suppose if query left is less than or equal to the left one, okay, and right is less than equal to query R. Okay, so what we can do, we can simply apply the delta here, self dot apply at index idx and what to delta, apply this delta, add to all. Now we can simply return. If this is not the case, simply go and first push the value, self dot push at idx, self dot push at idx, and then simply calculate the mid is nothing but L plus R double divided by 2, and yeah, now add it, self dot add idx into 2, the position will be k and our range will decrease to till mid, so L mid, QL and QR will be same, QL and QR will be same, and what will be the value, same delta we have to pass to the below ones. Okay, and then simply again self dot add from idx star 2 plus 1. Okay, till here the range will be till mid plus 1, mid plus 1 to R will be the range, and QL QR will remain as the query left and right range. Okay, and then pass the delta value. Similarly, you can update the minimum of that idx, self dot minimum of idx is equal to minimum of self dot minimum of idx star 2 comma self dot minimum of idx star 2 plus 1. If this works, and then same thing for the maximum, so self dot max of idx is equal to max of self dot max of idx, and yeah, same thing with this max one also as we have done for the minimum above. So self dot max of idx star 2, and then yeah, increment the by 1. So this completes our add function. Now the thing is left, what to all, yeah, this leftmost 0 is still left, so let's try to create this function for the segment array. So simply create a define leftmost 0, this is only the name we have given, I think, leftmost 0. Okay, and what all the values will take, simply again the index, then the left range, right range, then query left, query R. Yeah, so I think this all the attributes will be. Now we can again check if QR is less than L or R is itself less than QL. Okay, so we can simply return -1 in that case, as it is not possible. So again, if self dot minimum of that idx, self dot minimum of idx is greater than 0, okay, means 0 is not there, or self dot max of that idx is less than 0, then also we can return -1. And suppose if L is equal to R, left and right range is equal, we can simply return leftmost one will be this only. And again we will use the push function, push method help, which we have created above, and push this idx. Similarly create mid, define mid. Not mid will be just a half of sum of both, so L plus R, and we have defined caps L plus R double divided by 2. Okay, similarly set result is equal to self dot leftmost, again call the recursive function leftmost 0, leftmost 0, what will be this, again the index will be multiplied by 2, will be the twice, and my range will become L to mid, QL and QR will be same, query range, query left, query right, so QR idx into 2L, and yeah, mid we have written as mess. Okay, so mid QL QR, and then we can simply check now if result is not equal to -1, we can return result. Else what we will do, if it is equal to -1, we can simply return self dot leftmost 0, which give us a 0 balance array, right? Leftmost 0 idx into 2 plus 1 mid plus 1 will be the range till R, new left has become mid plus 1, and range will be again till R, and QR will be same, so query left, query R will be same. So I think let's complete our code. Let's try to run this and hope this works. Okay, run it again. Seems some network issue. Just a second. Yeah, so now try to run and check if this works. Okay, so now try to run and check if this works. Okay, name access not defined. We have use X. Okay, it will be idx, typo mistake. Let's try to run and check now. Take but 6 were given. Okay, again there is an issue. Which line? Segment dot leftmost 0 1 1 comma. Okay, and where is the leftmost one? Okay, we have not passed the self keyword here. We'll pass the self. Again try to run and see if this works this time. Okay, so test cases have been passed. Let's try to submit and check. It's taking a longer time. Yeah, so our code has passed successfully. Thank you for watching.